in different locations. This area looks like it has been managed somewhat. It looks like there's additional channels here, or perhaps the water level is a bit higher. Let's go back to that and pull up, go a bit further into the delta here and see what we can find. Perhaps if we look at, let's see, unfortunately we don't have any right in that region, but we do have some here.
So what's happening here is it's kind of just using our API, diving into our imagery archive, and it's telling us that we have 12 pictures over that specific spot.
Right. So I have this one that was collected on the 28th of January. It's in the Mekong Delta. I would hazard a guess, this is probably the most current image or current data for this specific location in the Delta, because no one is probably actively collecting data over this location. And again, the opportunity to get this information on a regular basis, use it very quickly. You see again that most of this commercial base map is cloudy. That's probably pretty common for the region. But then we can again, this is data that is just less than a couple of months old that I could use to assess what is going on currently in this part of the world.
Do you want to try and put that into the lab setting too?
Yeah, that's a good idea. So we've also, these are all browser-based tools. This is, again, this is just a regular Google Chrome browser. We've developed a few different tools that allow us to analyze data quickly. So even though many of you are probably used to taking satellite imagery into a GIS, a Geographic Information System, we've got some tools here that can quickly help us understand perhaps, what's going on, give us some ideas about current conditions on the ground. So I'm just going to have to log in here real quick.
Everyone look away. Don't remember the password.
Don't remember my password. So what I can do here, so rather than making the image appear on and off, I can actually look at some somewhat recent or not recent base map imagery. Or if I'm working in my own environment, one thing that we're building into the capability is if you have your own data that's perhaps a bit older, you could compare, or two scenes of planet data to compare together. But again, this is collected from different times of year. Surprisingly, this image is a much lower spatial resolution. You see at this zoom level, it's quite pixelated, so it's hard to see specific details. With this image here that we have, even though it's at a 5-meter resolution, we can actually see very, very specific types of developments, new roads and things like that are appearing. Like right through here, there seems to be some infrastructure that's been put into place. Yeah, so that's a way to quickly do that. Another thing that I think is quite powerful, and you can imagine doing this on a regular basis as you are monitoring a particular area. I can go to the same location, and then basically I have my base map or whatever my most current data set is, and then I load in the newest data that has just maybe come down yesterday or within the last few days. So on a regular basis, I could quickly scan my area of interest, and everything inside the circle is the newest available data. And again, to get an estimate of what's going on in terms of human activity, agricultural activity, flooding, those sorts of things. Again, these tools are running in a basic web browser. I can sit at my desk and do this. This data is all in the cloud, so I haven't downloaded anything. I haven't had to download very large files. If I can operate a web browser, I can actually access this data and begin understanding what's going on in my area of interest.
And humans still are possibly the best change detection algorithm or machine out there. That the human eye is just very attuned to spotting changes and changes that signify human activity. One thing that is under development is a set of automated change detection tools. So when I described the radiometric correction process we went through to build the mosaic, the other side effect of that process is that it makes the data standardized. So we can run small algorithms that look for color changes and then automatically alert ourselves and other people using the data to significant changes that may be underway. You could possibly then use our data to have a look with the eye to try and get more information. Or one thing you could do is potentially fly, send a person to the region or send a higher resolution camera mounted on a plane to have a look at an area where you think change that is significant is occurring.
Yeah, I wanted to also show this just to give you a sense of the capability of the satellites. This is a strip of data. So this is one of our satellites orbiting over China, going down further south over parts of Thailand, as you see here. This just happened a couple of days ago. This is the date that it was collected on the 17th of March. Here I have the total number of images that was captured. That was 342 images. Each of those images is 100 square kilometers. So again, a satellite the size of a shoebox, a satellite the size of a loaf of bread, captured international data across China, across Thailand, data that is several thousand square kilometers. The other interesting thing that you start to see in this particular data set, since this was captured just a couple of days ago, you can begin to see regions of heavy smoke in parts of northern Thailand. So a lot of these images right here that are labeled in red, they were not orthorectified by our automated tool simply because there was so much smoke in the atmosphere. So even monitoring very large areas on a regular basis, if we want to know, when smoke is building up in the atmosphere, you see a large amount of smoke in the region. And I was looking at this particular strip a couple of days ago when we collected it, and I could actually see in some of the regions some of the fires that started. I'm just going to see if I can pull one out here as I scan down. Yeah, here's one right here. So this is in Laos, but I can see right there where the smoke is the thickest. I can actually even see the origination point on the ground where the fire started. And again, this is data that's 2 days old. Typically, when you're getting satellite imagery data and having it processed to be able to use, it's a process that typically takes weeks to months, not just hours. But again, I think the interesting thing is this is a very timely topic of discussion. But understanding, obviously, what's going on below the smoke is obscured by clouds. But if I have a data set that we collected maybe from the previous week or the previous month, then I could then actually pinpoint the specific field or a very specific location where that fire started. So from an environmental perspective, this could be a very valuable tool. Are there any other regions of interest or questions that anyone has?
Yep, in the back.
Sorry? Where am I looking?
Just
hi.
to the right of the camera.
Hello.
Just out of curiosity, I just wanted to see the DMZ between North and South Korea.
Sure. Let me go back to our browser. Now again, I've said this before, but just to remind you that this area where we're collecting data is typically with less than 20% of our capacity. So you see a lot of gaps in the data set. This is only with about 20 satellites. As we add more satellites, then the coverage fills in and the frequency fills in. We'll see if we have some, I think we might have a few